Alright campers, happy Friday. This is our last Friday class, and this is the last video I'll be producing for this, but this video is going to be paused here and there so that you can kind of stop and review it, and then I can write a little bit just to try and keep the time down on it. So let's get started. Greatest common factor. The first rule of Fight Club is don't talk about Fight Club, but this is factoring. So the first rule of factoring, numero uno, is take out the greatest common factor. So 14 kind of looks like 2 times 7 times y squared, which is y times y, plus 3 times 7 times y. That's kind of what it looks like. So what you're doing is you're taking out a common, busting out common factors. So they have a 7 in common, they have a y in common, and that's what you're actually taking out. You're bringing it out in front is what you're doing. So what you end up with here outside is 7y, and on the inside you end up with what's left. That's the 2y and the 3. So that's going to be left with 2y plus 3. And if you were to actually go back and FOIL that, you would notice that you would get 7y times 2y is 14y squared. And 7y times 3 is 21y. And so that's the idea. That's the technique there. Bringing out the greatest common factors. They don't disappear. They don't get divided off or anything. They're just factoring. Remember, right now, there is no x equals. It doesn't exist. There's no equal sign, so we're not solving for x. We're just factoring. So now, once again, let's go with the 2 here and take out the 2 on this one. And you're left with x squared plus 5x plus 6. And you say, okay, well, can I factor even further? We can, actually. This one I'm not going to spend too much time on technique, but what you are looking for here is, when you factor these trinomials, the only way to get x squared is x times x. And you're looking for 2 factors of 6 that add up to 5. You may have seen this as a diamond problem up here like this, where you put the 6 on top and the 5 on the bottom, and that actually is that product on top and the sum on the bottom, or, as some people say, A times C on top and B on the bottom. But you can do this by inspection. So in this case, 3 and 2 is 5. 3 plus 2 is 5. 3 times 2 is 6. So you can actually just say it's x plus 2 and x plus 3. This is, after all, an Algebra 1 review, not the first rodeo here, folks, for you or for me or for anyone, hopefully. It's just picking up the skills. So that's our first spot right there. And there we are. We factored that thing successfully. So factored. Let's move on and factor some more. So let's go right over to these x squared minus. Now I'm going to do this one with the diamond, that method. So what I'm really doing is I'm doing 1 times negative 20, which is minus 20, or a times c. Now that's if you have that ax squared plus bx plus c. It has to be in that format, so in that trinomial, standard form. And on the bottom we put down the sum, which is b here, which is minus 1. So it doesn't matter which form you're using, you're doing the same mathematics here. You're looking for factors of 20 that add up to negative 1. And you can kind of see that it's not going to be 20 and 1, it's not going to be 10 and 2, it's going to be 5 and 4. 5 times 4 is 20, but one of them has to be negative, and to get to the negative 1, then the 5 has to be negative. And when x is 1, you're done. That's it. You're right. At that point, you're literally writing those, taking those factors and just dropping them in. X minus 5 times, right here, x plus 4. That's it. When a is 1, that's all you have to do. It's just a short process. And then over here you come to the next problem and you say, oh, well, a is not 1. Well, that's because there's a greatest common factor. Remember? First rule of factoring, take out the greatest common factor. So that's going to be a 2 times x squared plus 7x plus 6. And now I can see that 2 can be factored here. Once again, you can use the diamond, or you can just ask yourself this question, because this is the mental math. What factors of 6 add up to 7? That is 6 and 1, because 6 times 1 is 6. 6 plus 1 is 7. At that point, x plus. Check your signs. Everything's positive. So we are done. I wanted that to be more dramatic. We are done. All right. And then this last one over here, I'm just going to inspection one on this one. I got x and I got x. I've got 18. So if I do a diamond, I've got 18 times 1 is 18. That's my a times c. And negative 9. Looks like 6 and 3. because 6 times 3 is 18 and 6 plus 3 is 9, but because b is negative, they're both negative. Negative 6 times negative 3 is also, so you got to check your signs. And we are done. All right, so that's factoring when a is 1, you've got this kind of concept where you have a times c in your diamond on the top, b in the bottom, or what we say that's the product over the sum, and you're kind of looking for those two factors, and at that point that's it. Now when a gets bigger, the whole thing gets bigger. So let's move on here. All right, these ones all have either greatest common factor or they're factorable in one step using that diamond and box. So I'm going to pause the video, do the work, so you don't have to watch it over and over and over again because you got the instruction there. And let's do this. Pause. Okay, and unpause. These ones were all kind of one step here. The first one, we had the common factor coming out, and then boom, done, factored. Second one, 10 and 1. 10 times 1 is 10. You need both 1 and 10 need to be, you got to pay attention to your negatives right there. So pay attention to that negative 11. That's a big deal. And done. And the last one, 6. Basically, factors of 6 to get 5, it has to be 3 and 2. And in that case, they're both negative. All right, moving on to grouping. Grouping is literally doing this. It's not the same. It's just like the first thing we did, greatest common factor, because you still are, guess what? Rule number 1 still is rule number 1. Looking for greatest common factors, but you're doing that in the sense of in small groups. You're not doing the whole thing. So you're putting it into groups and doing each one. So in this case, x is common, x plus 2. And if you're not sure, go back and review the greatest common factor. So that's the greatest common factor of that little 2-piece equation. Then over here we got 4 comes out, and we're left with x plus 8. So oops, x plus 8. That wasn't too smart. X plus 2. Yeah. And then you take your two common factors. There's one of them. And then what's left goes together. So you're left with x plus 4 going together as one factor. And then x plus 2 going together. So what you're doing is you're actually greatest common factoring out the x plus 2. And what's left is the x plus 4. All right. So that's factored by grouping. It's not that difficult to do. It takes a little getting used to sometimes. So let's try this second one. I'm going to pull out the s, and I'm left with s minus 1. Don't forget the 1. It's important. It is. And then if I've got s minus 1, I'm going to pull out over here the 4. I'm going to be left with s minus 1. So there's my s minus 1 is my common factor. I pull that out now. It's like doing GCF 3 times. You do it on the first group, you do it on the second group, and then you do it on the whole thing at the very end, except you're pulling out a binomial factor. So what's left? You're like, oh, God, what's left? I don't know. Let's see. If s comes out, that means s and plus 4 is left, so that's why I've got an s plus 4 as my other factor. All right, and this last one I'm going to do kind of down over here because I'm out of space. Let's go with, take out the 2. What's left? Oops, got to take out a 2y, by the way, on that one. Got to take out a 2y. And I'm left with y plus 1. And on the right side, I'm taking out the negative 10. So I'm going to not put a positive there. I'm going to take out the negative 10. And I'm left with y plus 1. And then it's just a matter of 2y minus 10, bring them together, and y plus 1. Now, I can go a little further with that, actually. I can take out the 2 from this first factor here, and I can get 2y minus 5 and y plus 1. Now, what I forgot to do, I forgot the first row. I could have taken that 2 out in the very beginning. I chose to take it out in the very end. That's okay. So let's see. Let's go to number 11 real quick, because oh, wait. It looks like greatest common factor. 8, 64, 8. But then right here, no. There's no greatest common factor because there is nothing in the R. So I got to go back and just take out the 8 from the first group. Actually take out an 8R. I'm left with R squared. Oh, no, wait. I can take out R squared right there. R squared is my greatest common factor. I'm left with R minus 8. In my second group, I'm left with R minus 8, but what do you do when you're just left with the r minus 8? Take out a 1, because there has to be a placeholder, so that you end up with 8r squared minus 1 times r minus 8. All right, and over here, I'm going to do another quick grouping over here. Take out the a, and you get the a plus 3. Take out the 4, you get the a plus 3, because they always match up. These two guys right here always match up. And then when you factor them out, they come out once, not twice. It's not a plus 3 squared. It's just you take out the common factor and a plus 4. That's factoring by grouping. Mr. May's favorite way of factoring. So let's keep on keeping on. We're looking good so far. Now, this is where the rubber meets the road. So I'm going to pause in the action for a moment and come back. There's a couple of different ways to do these ones. And this is, by the way, this is when ax squared plus bx plus c, this is when a is greater than 1. In other words, you have a number up there, not 1. So we're going to take a look at that when we come back. But right now, we're going to take a short commercial break and pause. All right, let's talk factoring when a is greater than 1. Different methods. One is the divide or slide and divide. In other words, you take your a value and you slide it over here and multiply it. So you get x squared plus 3x. Oops, that's a really ugly 3. Let's fix that. 3x minus 9 times 2 is 18. That's the slide. And then you just factor as normal. That's going to be x 18. 6 and 3 is 18, and that means that 6 is going to be positive, 3 is going to be negative. So I'm just doing my normal factoring. And now here's where it changes. At the end, you've got to actually divide that coefficient off. So you've got to divide that 2 again, and you put it at the end. You divide this by the factor. And what happens here is if it divides evenly, you're done. That's going to be x plus 3. And if it doesn't divide evenly, you're going to have to take that. You don't want decimals or fractions. You're going to have to take that divided by 2, and you have to bring it back out in front, because that's actually how you're getting the 2x squared. So you're going to have to bring it out there and get the 2x minus 3. And you can see if you FOIL it you can always double check it by seeing, okay, there's your 2x squared, there's minus 3x, there's plus 6x, so that'll give you your 3x in the middle, and then 3 times negative 3 will give you your minus 9. So it all checks out. That's called slide and divide. Check out the video on that. It actually works really well. It does. Trust me. The other method I'm going to highlight here is the X box method. This method also works well. It's a little bulkier, but it's doing the same thing. It's just not quite exactly. So what you do is you do the diamond up here, and that's, remember, the diamond is a times c over b. So it's the product and the sum. So a here is 5, so you get your a there, your b there, and your c there. Don't forget standard form. So 5 times 12 is 60, and then in the middle, 19. So you're looking for factors of 60 that add up to 19, and then, hopefully you can do this mentally now. Well, 60 times 1, that ain't it. 30 times 2, that ain't it. So you could go on and on. It's actually, if you think about 15 times 4, that's it. 15 and 4. 15 times 4 is 60. 15 plus 4 is 19. So that's how that works. And what that does is, here's what's actually going on here. Here's what's going down. You are taking that 19n and splitting it. So you're splitting it into 5n squared plus 15n plus 4n plus 12. Now, there's an x in a box. This is not the x box method. I think I said I was going to do that, but I'm actually just going to then factor this by grouping. Group, and group. And then I'm going to go, okay, that's going to be 5n times n plus 3. Plus, I'm going to take out the 4 over here, and that's going to be 4 times n plus 3. And now, so you can x group. That's a method. It's kind of a combination of methods, but it's called an x group, and that works. And then finish it off with 5n plus 4. We've already talked about grouping, so I'm just going to kind of finish this off by pulling out the n plus 3 as the common factor, n plus 4 is the inside. So you can slide and divide. you can, and all these methods work for any of these when a is greater than 1. It works either one. There's an X box method as well, which I'm going to just give this one a try for a moment. There's the X, there's the box, and there's my answer. Watch how I do this. It's still a times c, so you still are doing 3 times 4. You're still getting 12 up here and negative 8. So you're still doing this, the X the same. And now, factors of 12 divided up to 8. Let's see. 6 times 2? Yeah, that'll work. 6 times 2, except that that equals 12. But to get negative 8, the 6 has to be negative, and then the 2 has to be negative. And what that does is it splits the middle term, but you split it in the box. The box is just a graphic organizer. It's the same thing as grouping. It just looks a little different. So I've got 3n squared. Oh, these are n's, by the way. Oops, I put x's, n's. And then a plus 4. So you take your first term, your last term there, and you split the middle term, and now you factor greatest common factor. And that's actually what you were doing with grouping anyway. So you're going to go up here and get an n here. So you're factoring kind of up each column and across each row is what you're doing. So over here I'm going to get 3n, and that gives me my 3n squared. So now I've got my n here and a 3n. That's part of the two factors. And then I go down here, I've got a 2 over here and a 2 over here, and it looks like they're both negative. Hold on a second, what's going on here? Where's my 3? Where's my 3? Oh, I took out the 3, that's right. Okay, so that's 2, yep. So what I get is n plus 2. Oh no, they both have to be negative, don't they? So I get n minus 2 and 3n minus 2. And if I factor, once again, if you FOIL that out, you get the positive 4 on the end, you get the 3n squared on the top. That's your first term, and then in the middle you get minus 6n and minus 2n, which is minus 8n. So that's the X in the box. All right, that's just the other technique, if you will. Pick a technique, they all work. I like this one. I'm going to use the slide and divide. So I'm going to slide the 6 over, and that's going to give me n squared plus 5n plus 30. Oops, that's a minus. Minus 36. One sign will ruin your day here. And then I'm going to put it into its factored form, and that is n minus and n plus, and I need to know. 36. 6 times 6? No. 12 times 3? No. Ooh, 9 times 4. Yes, because 9 times 4 is 36, but 9 minus 4 is 5. So to get positive 5n, the 9 has to be positive. And you can see that you would have come to that conclusion if you used the X. By the way, you can use the X here too. X, box, grouping, divide and slide, they all work out. Now I need to slide. No, I've already slid. I need to divide by that 6 up front. And it looks like this one, let's see what's going on here. 5 and 9. Oh, wait a minute, not 5 and 9, 4 and 9, right? I said 5. How did I get the 5? What was I thinking? Oh, because I was talking about the 5 there. So this little guy, let me just make a quick repair here. That was 9 times 4. 9 minus 4 is 5. There we go. Okay, that makes sense. So if these, here's the thing, on this one, if these, you got to simplify the fractions a little bit. So it's really n minus 2/3. You got to simplify the fractions. That's part of this deal. And then n plus 3/2. All right, and then when you do that, now I slide the old denominator back up because it doesn't work out evenly, and then I finish it off right here with 3n minus 2 and 2n plus 3. And I check it. 3n times 2n is 6n squared. Check. 3 times negative 2 is negative 6. Check. So the first and last terms. And then I check this guy. That's going to be 9n minus 4n, which is 5n. It checks out. So I know that I'm correct. I've checked it all out. All right. So divide and slide, most of the time it works out nice. Sometimes the X in the box are better. It just depends really on what you're doing. So let's do another one with divide and slide here. N squared plus 19n plus, I'm going to slide that 5 over. 5 times 12 is 60. I feel like I just did this problem. Something similar. So let's do it again and just see if it's similar. N, 60 is 15 times 4. Yeah, I believe this is the exact same problem that we just did. N plus 4. So n plus 15 times n plus 4. And then you're going to divide out that coefficient, that leading coefficient of 5. And remember, if you do that and it works evenly, you just do that. N plus 15 over 5 is 3, so that's just your n plus 3. And then over here, if it doesn't go evenly in, you slide that coefficient back up where it belongs to get 5n. Because I'm trying to get 5n squared anyway, so I know 5n is really my only option there to get that 5n squared. And then plus 4. All right, and I'm out of room, so I'm going to leave that last one alone. You can try that one and solve it yourself. How about that? Actually, there's no solving. Simplifying. Okay, and then we come to the end of our conversation here is the difference of squares. First of all, look up here. This is the formula for difference of squares. It's really just a pattern. So it's x minus 5 times x plus 5. The reason being because minus 5x and plus 5x cancel each other out. You end up getting that difference of squares if you multiply it out. So there it is in factorial. These are actually the quickest part of this whole conversation. So you're looking for the square root of each term. 25x, that's going to be 5x times 5x. 121, square root of 11. So they are perfect squares, but they're not the sum of squares. It's the difference of squares. So it's 5x minus 11 and 5x plus 11. I think the word they call these is conjugates. When you multiply them back together, the middle term drops out. So I can do quite a lot of these. I also want to remember to factor out the greatest common factor first. Don't forget the first rule of factoring, because 32 and 18, 2 comes out of that. So I get 16x squared. And there's my perfect square, minus 9. Okay, now don't lose the 2. It doesn't disappear. It just stays out in front there, and you get 4x and 4x. So you get 4x minus 3 and 4x plus 3. And over here, 49, that's going to be 7x minus 9 times 7x plus 9, because I'm just looking at the pattern here. That a minus b times a plus b. So 4 minus x, 4 plus x. Don't forget to put your parentheses on it, and you're good to go. All right, that concludes the final video for 2020, and you know what that means? Yep, that's it. See ya.